Algebra 2 Common Core, trig graph translations. So at this point, you're very familiar with the basic sine and cosine curves, and you learned about dilations. You learned about amplitude, frequency, and period. Well, and we also, how when we reflect the x-axis by having a negative coefficient to sine or cosine, multiplying the function by a negative value reflects it over the x-axis. So we've seen that. We've seen amplitude, frequency, period, basically the dilations and the reflections. Now we're going to talk about the translations. And that's, if you remember, it's kind of like a shift, side to side, up and down, things like that. And that's what we're going to see. We're going to see horizontal shifts, and we're going to see vertical shifts. Now, horizontal shifts, meaning left or right, they take place when there is plus or minus something inside the parentheses with the x. That's what's going to move side to side. Now, a little counterintuitive that when you see something with a plus in there, it actually goes left, not right. It's a minus that makes it go right. And again, this is the same thing for regular graphs, parabolas and exponential or whatever. Like if we compare, just x squared to the graph of x plus 3 squared, we'll see that this graph is this moved to the left by 3. That plus 3 means left 3. And if it was a minus, it would go to the right 3. Things like that. And then the vertical shifts are probably the easier of the two. That's what you'll see on the end. We use K for that one, and that is simply when you see plus, it goes up, minus, it goes down. And again, that's the same. If I look at x squared, it's at the origin. If I do plus 3 on the end, the whole thing will be moved up 3. You could explore that on your calculator, and we'll talk about translations throughout the year. And so let's look at some of these horizontal shifts first for sine and cosine. So first, let's just take a look again, get our basic sine curve up here. So y equals sine x, and this is going to be graphed over a 0 to 2 pi domain, or a 0 to 360 window. And we see that that's just one basic wave sine. It's frequency of 1. It's ending at 2 pi. It has an amplitude of 1. That's as basic sine as it can get. Now, what you see here is this minus pi over 2. Well, that's the same thing. The minus means that it's going to go to the right, and pi over 2 is the same thing as 90, right? Now, my calculator, it depends on what mode you want to work on. My calculator mode is set to degree right now, so it wouldn't really understand if I typed sine x minus pi over 2. I'm actually going to have to write plus 90 or something like that. So this minus pi over 2, if you're in radians, you could type that, but if you're in degrees, you would have to write x minus 90, which is what I'm going to type in because my calculator's on degrees. I could easily change it to radians, but so let's do x minus 90. Well, actually, let me keep that as just sine x, and then in the red, I'll do sine x minus 90 so we can compare these two. So again, here's your regular sine curve in blue, and then your red one, the whole thing should be moved to the right 90. Now, we don't really have like marks here, but and I'm not sure I could draw on this, but this is 90 degrees, where the maximum height is for sine normally. Notice that that now is at 180. The whole graph got shifted over to the right 90 degrees. And by doing so, it actually now looks like negative cosine. And that's that strong connection between sine and cosine being co-functions, being complement functions, that they are each other 90 degrees apart. And in fact, if I were to take sine curve, instead of moving it to the right 90 with a minus 90, if I move it to the left with plus, remember plus is left, which is a little counterintuitive, but if I go to the left 90 instead, so regular graph, sine graph in blue, I get the cosine graph in red, which is the sine graph shifted to the left 90, where I'll take my max over 90 and then move it over so the max is over 0. I get the cosine curve. So that's what moving them side to side is. A lot of times you just be able to look at this and see what it's saying here, that this minus pi over 2 is right 90. This plus pi is left 180, or left pi. And then this minus 2 pi is right 360. And what am I going to notice when I move the graph 360? It's going to look exactly the same. Because moving the graph 360, is 360 is our interval where it's changing. Now this also has an amplitude of a half, but that's just going to make it a little bit tighter to the x-axis. Vertical shifts are actually, I think, a little bit easier to understand. It makes sense that plus is up and minus is down. So if we look at these graphs, let's explore these a little bit here. So let me go to my y equals. Yeah, all right, got that selected. So y equals, and I'll keep sine x in there. But now let's change it to sine x, close the parentheses, plus 2. And so one big difference about horizontal and vertical shifts, remember that your horizontal axes are intervals of degrees. Like this is 90, 180, 270, 360. But your y-axis is still just regular numbers, like 1, 2, 3, 4. So you'll see like minus 90 inside, but then you'll just see like minus 2 outside. So inside is degrees, outside is regular y-axis, 1, 2, 3, 4, 5 stuff. So, all right, back to here. What happens when I hit a plus 2 on the end? I'll get my regular graph in blue, and then the red graph is going to be shifted up 2. And so everything got moved up 2. And you would see, of course, the same thing as you could predict if I were to change it to minus 2, the whole graph would go down 2 from the original location. So again, the original in blue, and then the graph moved down 2. So that, is pretty straightforward as far as the translations go. But what you do need to know is when a vertical shift happens, a lot of things change, but what doesn't change is the amplitude. Like looking at this graph here, the regular blue graph has an amplitude of 1. Right, so 1 above the midline. This red graph still has an amplitude of 1. Now the maximum changed. The maximum is no longer 1, right? The maximum's down at -1. The minimum's down at -3. So the maximum and the minimums change. The range changes. But when you talk about amplitude, amplitude is the height of the wave above the middle of the wave. So the middle of the wave would be here. We would call it the midline. And it would be the equation y equals 2. Actually, let me see if I could plug that in here too. Show you what I'm talking about. Let me plug in y equals 2. And you'll see that I'm sorry, y equals -2. Right. Let's do -2. Y equals -2. You'll see that that line is the midline of this graph that shifted down 2. And it actually works out that whatever your vertical translation is, that is the equation of your midline. So for this equation right here of y equals sine x minus 2, this minus 2 after the parentheses, that is the equation of the midline. And it's helpful to know that because, again, my amplitude is not changing, but other things are. And so the midline is this equation y equals k when you have a plus or minus k on the end. So, remember inside the parentheses is side to side, plus left minus right, and it's going to go in angle increments. And then outside the parentheses is up and down, plus up, minus down, but the amplitude doesn't change. It does change the midline, it does change the range, it changes the max, it changes the mins, but that's really all that it's going to change. Okay, so let's see here. I don't know why this is here. This is, I think this was supposed to be a closed parentheses -1. But we can see that this is going to go up to, if this was drawn correct, let me rewrite this, y equals sine, close the parentheses x, -1, that's going to go down 1. So a couple of things. Because the midline is no longer always in the middle, it's very helpful to know where that is. And a lot of times we could get that from the maximum and minimum values. And so if you have the maximum and minimums, a lot of times, we'll get a word problem that's describing a trig graph, and they'll tell you things like maximum, minimum, period, and then you need to interpret that stuff into amplitude, midline, frequency, so we can create the equation. So it's a lot of going back and forth. Sometimes you have the maximum and minimum and you want the amplitude. Sometimes you have the amplitude and the shift and you want the maximum and the minimum. So it goes both ways. But if you subtract the max and the min, divide by 2, you get the amplitude. If you add them, divide by 2, you get the midline. We're gonna talk about this a lot when we get to modeling with these things. Right now we're just getting used to graphing them, but we will talk about modeling situations that involve these, so we're gonna talk about this a lot. But it makes sense that your amplitude plus your shift gets you the max, and whatever your amplitude is minus your shift, gets you your minimum. Okay, so let's look at one example and run through a couple of things. So here is this monstrous equation here. Okay, first thing, amplitude 4. Got it. Frequency, coefficient of x, might be in front of a parenthesis now. That's 3. Period is still 2 pi over frequency, so 2 pi over 3. Okay. Horizontal shift is this plus pi over 2. That means left, and I'm going to use degrees 90. Vertical shift is down 1 for that minus 1. My midline, therefore, is y equals negative 1. From that midline, so from your midline, I can plus the amplitude to get the max, and I can minus the amplitude to get the min. And that's really what this is saying here. So then our maximum here, if our midline is y equals negative 1, and my amplitude is going 4 above that, so plus 4, my max is going to be at 3. Minus 4, my minimum is going to be at negative 5, and so my range is from negative 5 to 3. And let's just type this graph in real quick, and I'll show you what it looks like. So 4 sine 3, let me clear all of this out. Get up there. And it's 4 sine 3 parentheses x, and it was a plus or minus, plus pi over 2, but I need to write plus 90, close the parentheses, close them again because it opens automatically for me, but I had to open another for the plus 90, and then a minus 1. And let's take a look at what this thing looks like. And because of all the shifts, it's going to look a little weird, but I can see that my height, my max is quite, it's not centered. Everything's been moved down. What we have here of a maximum of 3, I see that, and a minimum of negative 5. To really see that minimum, I'd have to change my window. For my y graph, I'd have to go down to negative 5, where I'll do negative 6, so we can see a little bit of a cushion there. But you'll see my max goes to 3 and my minimum goes to negative 6, and the graph is centered at y equals negative 1, which again I could type that in to visualize, but I think you get the point. All right, so that's kind of putting all this together, and this gets real important when we get into the modeling situations for these graphs. All right, that's it.